I just finished creating a fully type-safe router inside of React entirely from scratch. As you can see, here's the router working in action. It has loading states for different loaders. It has navigation programmatically as well as through links. And most importantly, everything is entirely type-safe. As you can see here with my link component, for example, I can only navigate to the links that I've defined inside of my route, which are these 3 specific links. And if I define a link that has a dynamic parameter, I must pass that along. If I, for example, don't pass along any parameters, you can see I immediately get an error. Or if I pass along the wrong type to my parameter, you can see I'm also going to get an error. So it's fully type safe in that regard. On top of that, it also has support for loaders, which are all going to be entirely type safe. You can see it has different loading states, as well as here you can see I get the full type safe return from it. So you can see here, it's a string hi right here, and that is what's being returned down there. I also have navigation doing programmatically by like button clicks as well as links. And then finally, we have parameter based things as well. Again, entirely type safe. If you look over here, my parameters is an ID that's a number. So this project pretty much encompasses everything you would want in a basic router inside of React. And in this video, I really just want to kind of go over and show you the code, the different things I talked about, how I approached this problem, the things that I learned from it, and overall just show you how this code works and everything related to my thought process for it, so that hopefully you can take these learnings and apply them to your own project and be able to see how to tackle some of these more complex, especially TypeScript related projects. The style and design that I use is actually somewhat related to TanStack router and React router. So if you're kind of curious how some of those routers work behind the scenes, I did some things that are similar to what they did. Obviously, it's not exactly the same. Theirs is much more complex, but I used some of the similar tips and tricks that they use. So it's really cool to be able to see these different things in action. Welcome back to Web Dev Simplified. My name is Kyle, and my job is to simplify the web for you so you can start building your dream project sooner. And building a really simple router with loaders, params, and links that doesn't have type safety is relatively easy to do. For example, what I have over here is not hard to implement without type safety. But as soon as you want to add type safety into something like this, it becomes significantly more complex. So I decided to be able to try to tackle that problem myself to really see what goes on behind the scenes. I want to share that information with you. And to get started, I first want to show you the code that's not inside of the router library to show you how using this type of routing library works. The main way that this works is you define routes using this define route function, and you pass it the URL that you want your route to look like. This is very similar to how TanStack works with their router, or how a React router or something like that would work. You just pass it along the path to your particular route, and then you can pass along a bunch of different parameters. As you can see here, we have the component that we want to render, any optional parameters that we have. We can determine if this is a layout file or not by passing in true or false. This determines if it wraps other components or if it's a standalone component on its own or is inside maybe as a child component. Also on top of that, we have the ability to pass in a loader, and this is just to do any type of asynchronous loading when the page first renders this component. Relatively straightforward information there. So those are all the different things you need to pass along, and really the only required thing is going to be your component. That's the only thing I'm forced to pass along to this particular thing. Now the reason I'm getting an error here is because I have a parameter defined inside my URL, so I'm required to pass along a parameter with that. So to fix that problem, all I need to do is pass along params, which must be a Z object, so it must be a Zod object. And then for this Zod object, I'm going to have an ID property, which is going to be a string. Actually, let's make it a number. That's what I had it at before. So there we go. You can see now everything is working fine. And that's because I had a parameter inside of here. If I remove this parameter, you can now see I get an error because I don't have any params in my URL, so I shouldn't be adding parameters. So there's a ton of type guards put into this particular code. So that's pretty much how all these different routes work. They're all essentially the exact same. Some have loaders, some don't, some have parameters, some don't. Otherwise, it's all pretty similar. So that's how you define all your different pages. And then the main bulk of your code goes inside this routes. And inside of here, we have our router provider. Pretty much any routing library is going to have a context that wraps everything. That's exactly what this does. It just wraps our entire application inside of our routes. And our routes are defined right here. And this is a very simple file. All I'm doing is I'm taking every single route that I've defined in my application. I'm importing them into this file and then exporting them. So I'm just importing each of the routes, putting them inside of an array, and then exporting them. And then to make all of the TypeScript magic work, I'm essentially declaring this register model with the routes set to the type of my routes. So all I'm really doing is I'm taking my library related code and I'm replacing the type for my routes with the actual type of the routes I've defined in my application. This is how all the different router libraries and even libraries like TRPC work to give you type safety with their code inside of your code. They just make it so that you essentially override one particular section of their TypeScript code, and then they use that one section everywhere in their code. So whatever my routes are, it's going to use that inside of my router library. So setting up this router is actually incredibly easy, and it's actually kind of nice because all of the different things related to how my routes are laid out are all in the individual component that defines that particular file. So my component and the routing information are all in the same place, which makes it easier for me to reference every single thing inside of my code. Another important thing to understand is I have access to a few different hooks. The main hook is the use router context. That gives me access to navigate. It gives me access to a few other things, but really the only thing that I care about is navigate. If I was creating this as like a real world production ready library, I would make sure not to export certain things like the loader data and the matched route because those are used internally inside of my router system. But since this was purely for an experimental purpose, I just left them as an export. So you can see here, navigate is again type safe. You pass it in a URL and then you can optionally pass it some parameters. And again, this is all type safe. If I come in here, you can see I get a list of all my different URLs. And if I pass a URL that doesn't require parameters, I'm forced to not put any parameters inside of there. So this is again, all type safe related information. Also, my route has two different hooks that it exports. So if I come in here, you can see I have two main hooks, the use loader data and the use params. These are the hooks that actually allow me to hook into the information I need. So use loader data, all it does is it just gives me my data for my loader if it's there, and it gives me the state for what's happening, as well as an error state if I have an error. So I essentially get the state of the loading, the data, as well as the error. There's lots of different ways to implement this, but this was the easiest to work with and I really liked how it worked. Lastly, we have the ability to use params. So this use params hook just returns whatever our parameters are, and it uses Zod to be able to make sure it parses those. So it takes this ID, which is a string in the URL, converts it to a number so I can use it here as an actual number. So that pretty much covers all of the different features of how this router works. So let's actually now dive into the code for the router, because this is where all the really interesting stuff happens, especially related to TypeScript. So the main first file you're going to run into is the router provider. And this is essentially the glue that holds everything together because it has this giant context. If we scroll all the way to the very top, we have this router context that contains the context for all the different things that we can do. The main important one externally is going to be our navigate function right here. And I actually already see a small bug in my code. This should be navigable routes. Let me just fix that. Navigable routes. There we go. We'll come back and talk about what the difference between those are. But these are all the different functions and things that are exposed. Navigate is the main one that you use externally inside of your actual application. And the rest of these are all used internally for how everything works. We'll come back to what each of them means. But the main thing I want to talk about is going to be the matched routes, because this is essentially what determines which route we're rendering and then all the different layouts that we're rendering as well. So if we look at where we're using matched routes, if we scroll down a little ways, you can see that we have this stored inside of a state variable. And then anytime we change our route, we're going to call this handle route change function. And what this is going to do is it's just going to take whatever the current URL is that our page is currently on. It's going to call this route parser function, passing in all the routes inside of our application. That's essentially the thing we pass into our provider, our array of all of our different routes. This array right here, that's essentially what that reference is. It's going to take that in our current URL, and it's going to get all the different routes that match for that. So all of our different layouts, as well as the main route itself. And then finally, it's going to give me a raw list of my parameters. It's not going to do any conversions or anything. It's just going to give me the name and then the string value for that particular thing. Then what I'm doing inside of here is I'm just setting up my base state for everything. I probably could have used a reducer to make this a little bit cleaner, but I ended up just doing it with state because it's not too complicated. I'm setting my routes, I'm setting my parameters, and then I'm defaulting all of my loaders to either no loader. So if this thing doesn't have a loader, it just sets the data to no loader, so the user knows nothing ever happens with the loader, or it sets the loading state to loading because it's going to start loading that information. Now, if we dive into this route parser function, this function looks kind of complicated, but it's really not too hard to understand what's going on inside of here. What I'm doing is I'm splitting my routes into two different types, my content route and my layout routes. And the content route is really easy. All I want to do is I want to find the URL that directly matches with the URL that I'm currently on. That's going to be the content route. So if I go to /about/ID1, I want to be able to go specifically and find the route that is for /about/ID. And if we look at this isRouteMatch function, that's essentially what this does. It just takes my URLs, it normalizes them, and this normalize function just makes sure there's the same amount of slashes at the end and the start of the URL, just because sometimes you could have extra slashes. I want to make sure it's all the same. And then it's going to split them on this slash symbol. So what it's going to do is it's going to split the URL into each individual segment of the URL. If they're not the same length, obviously they're not the same URL, so we return false. Otherwise, I loop through every single segment inside the URL, and if the segment starts with a colon, that means it's a dynamic URL. For example, my URL could be /about/ID like that. So in my /ID section, this is dynamic. It doesn't matter if I pass in 1, 2, 3, whatever the URL is, it doesn't matter. So essentially, if the segment starts with a colon, automatically return true because it matches literally everything. Otherwise, check to see if the segment matches the actual current URL. So if I have the URL route /about/ID, and I want to compare that against something like /contact, you'll see that /contact does not match /about, so it's going to throw me an error. If I come in here with /about/2, you can see this ID in this to section, they'll match because this is dynamic, it matches everything, and about are the same, they match, so all the different segments match, so it returns to me true. So really all this does is determine if there's a route match or not. If there is a match, then I know I'm on the correct page. So this is my current content route. If I don't have a match, I just return an empty array of routes and I return an empty parameter. This could handle with like a 404 state or something like that, but I didn't mess with that. Essentially, if I go to a route that doesn't exist, you can see it's just going to render a blank page because I'm not handling that state because it wasn't really important to my particular learning of this application. The next section is a little bit more complicated, and this is for matching all the different layouts inside your application. So I'm going through my layout routes and I'm trying to loop through all of them. But the thing about layouts is I don't need an exact route match. I just need to match everything inside of my layout section. So to take a quick example here, we can actually look at our code because I have multiple different layouts. For example, I have a layout that starts at the slash route, and I also have a layout here that starts at the slash about route. So if I were to, for example, try to access the route slash about slash 1, this is going to match both the layout for slash about, and it's also going to match my layout for just the homepage with a slash at the start. So what this code down here is doing is it's looping through all of my different layout routes and it's taking my normalized URL that's split on slashes. So essentially my route that was slash about slash 1 is going to be split up into essentially an array that looks like this, where you're going to have an empty string for the very first one, then about, and then you're going to have the value of 1. And all that I'm doing is I'm looping through that normalized array and constantly popping off the last value of it. And I'm checking, okay, does it currently match the URL? So does it match slash about slash 1? If it doesn't match, I pop it off and I look at the next thing. Okay, does it match slash about? If it doesn't match that, then I pop off again. Does it match slash? If it doesn't match that, then I pop that off and you can see eventually we get to a length of 0, so we know that it doesn't match. So all I'm doing is I'm trying to find the URLs that match any partial route inside of my list. So as long as it matches a partial route, then it's going to be matched inside of here. And finally, I'm sorting them in order. So it's always going to put the layouts that have the smaller list in a certain order and the ones that have a larger list in a certain order. And this just makes sure that I have everything ordered properly. So you can see at the very end, I have my most specific route. And then these matching layouts here are ordered in order from the lowest level all the way to the most specific. So for example, the route of slash is going to be very first in my list, slash about is going to be next. And then my actual route of slash about ID is going to be the last thing inside of this list. And lastly, I'm just getting my parameters from the route. This is a rather simple function that just takes whatever that colon section is and replaces it with the actual item inside the URL. So in the case where I had that slash about ID, if I had a 1 here, all it would do is return to me an object that has an ID of 1, just like that, rather straightforward. So the actual code inside of here, not super important to understand. Really all it's doing is it's looping through all the different routes that I have defined and it's determining what is the current route I'm on and what are all the layouts that I need to render myself inside of. So that's what we're getting inside of our routes for right here. So now that we have all the routes that we need to render on our page, the next thing we need to do is run all the loaders for those routes. And that's what this use effect right here does. It looks really long and complicated, but it's rather simple. All I'm doing is looping through each one of my routes. If I have a loader, then I'm setting the data to loaded, or I'm setting it to loading. And then what I'm doing is if it's a dynamic route, I'm passing along my parameters. Otherwise I'm not, because I sometimes have parameters, sometimes don't, depending on if it is a dynamic route or not. And then finally, what I'm doing down here is when my loader finishes, I'm getting the data, setting it to loaded. If there's an error, I'm setting it to error right here. So you can see no matter what happens, it's setting it to some particular state. And that's just happening anytime that my route or my parameters change. So overall, this entire use effect right here is just running the loaders every time I change my page. And this function, all it does is handle changing my page by updating all my state variables anytime my page change. We'll come back to this little use effect in a second, because the next use effect I want to talk about is the way that all of this works. Essentially, any time that I have a pop state event, which happens like when I click the back or the forward button, for example, it's going to listen to that event and it's going to make sure that I actually call handle route change. So it's going to update all my route information whenever I go forward or backwards, for example. Then to talk about what this use effect does, essentially this is kind of like a hacky way. I'm sure there's a better way to do this, but essentially the very first time I render my page, I want to make sure that I call handle route change. So this is going to call it the very first time I render my page. And also anytime I change my handle route, for example, if my routes change partway through my application running, I also want to rerun this function. This is something that probably will never happen in a real application because you probably don't change your routes dynamically while people are using your application. But if that ever did happen, this just makes it so that it's going to handle those changes properly. So if you change your routes, it'll reflect that and redirect the user if it needs to. Finally, we have this go to URL. I'm going to skip this pretty much because it's a hack that I put in place to not deal with a specific TypeScript thing, and it's only used in one specific section of code, so it's really not that important. Next, we have our navigate function. And this is the function that allows us to navigate between different portions of our application. And again, this should be my navigable routes as well. Again, I'll talk about why in just a second. What this function does is it takes in a URL and it takes in all the different parameters that you need for that. And all it's going to do is just going to push you into the state for that. So I'm taking my parameters, I'm looping through and I'm replacing my URL with the correct parameters. So for example, if my URL /about/id, and I pass in parameters of id equals 2. All it does is it takes this 2 and puts it right here inside my URL. That's all this little bit of code is doing. And then I'm navigating to that URL and I'm calling handle route change because I've now changed my route. I'll dive into the typing section for this in just a little bit, but the final thing that we have down here is I have my router context with all these different values. I then have an outlet because I'm handling everything using outlets, and then I have an outlet wrapper that wraps all my outlets to be able to make sure I render the correct layout in the correct location. I'll get to this in just a little bit again because it's quite complicated. But the first thing I want to talk about is all the different type related information that I have, because this is where the bulk of the complexity comes in with this system. And most of the complexity is in this one file right here, which is just a file that contains pretty much exclusively type related code. Now, before we dive too far into this file, I do need to open another file. Luckily, this one is a single line, so it's quite easy to understand. And what this one does right here is it sets up that interface that I can overwrite inside of the rest of my code. So I set up an interface called register, and I set it up to be completely blank. So by default, the register has nothing inside of it. But you'll notice in my application as a user, I define what the routes are for register. So as a user, I'm saying I want to override this with my own type of routes. So now inside this code here, you'll kind of understand why this code is written. I'm taking that register and I'm checking, that's what this code does. I'm checking, does it have a routes type defined in it? If it does not have a routes type defined in it, I'm going to default to something called defined routes with all these different default values inside of it. And if I go down to defined routes, all this is essentially just the most generic version of everything that I can have. So I have a route with params and I have a route with no params. And if I take a look at the code for those, it's rather straightforward here. You can see I have a path that's a dynamic path. I have params and I have a loader that takes in params. And my no params version has a pass and it has a loader as well. I know the TypeScript for some of this looks really complicated. We'll be diving more into it, but essentially these route with params and route with no params, when I use it down here in this defined route version, it's using the most generic version possible. If we scroll all the way to the very top of this, you can see it works with any Zod object. So my params is literally anything. My loader return value is unknown, again, literally anything. And whether or not I'm in a layout file or not is just a Boolean. It's either true or false. Again, it's the most generic version of anything. And the reason I need this generic version is so that all my types still work inside of my code. So my actual code I'm writing for my library doesn't know what your routes are going to be. It just knows it's going to be some form of defined route that's going to have this style of signature inside of it. And then you define what the routes are, which gives you type safety in your code. But for the code I write in my library, I don't obviously know what your types are, so I don't have that level of type safety. I need to take into account all the different permutations of what are possible. So if you don't have any routes defined, it falls back to the generic version. This is used for my library code. If you have routes defined though, that will be your specific routes and it'll go into this path here. Really all this complicated TypeScript code does is it just says, okay, I know what your routes are. It's going to have a type of route, and essentially it's just going to be the list of all of your different routes. So it's going to be a list of all those routes. And if we take a look here at our navigable routes, I can actually create a type here. We'll say type s is equal to navigable routes, and we're going to get the path. And actually I want to do these routes right here. And if we look at the path, you can see that this is your hard-coded path that you created because you overwrote those specific types inside your file. If I go into here and I remove this line of code, this is kind of the magic. If I come back into here, you'll notice that this particular section doesn't really have any type. It doesn't know what's going on because it's falling back to all these other things. That's the line of code inside everything that just hooks up all the glue to make everything work as we expect it to. So this is essentially making it so that our code works with your defined types as well as the generic type for defining the library code. Next, we have navigable routes. Essentially, a layout file is not a file I can navigate to. If we look at my code, you'll notice a section here where I have a route for /about/id. I have another one here /about/id/child, and I have a layout that wraps both of those by starting with /about. But I don't have any page at /about. If I go to /about, it's not a page I want to be able to navigate to because it's a layout only. So really all that particular code right here is doing is it's saying, hey, all the routes that are layout routes, completely ignore them. So this only returns to me routes that are not layouts, which are the routes that I use for things like links, navigation, and so on. Dynamic route is a little bit of a special type here. It's really a helper type that allows me to determine is a route dynamic or not. Essentially, this just checks, is there a colon inside of your route anywhere for a route parameter? If there is, then it is a dynamic route. Otherwise, it is not a dynamic route. And I even have a helper function down here called isDynamicRoute that takes in a route. kind of ignore a lot of this TypeScript stuff right here, but really all it does is it takes in a route and it determines, does this route have parameters or not? If it has parameters, it gives me the type of route with params, and if it doesn't, then it doesn't give it any type. This is really useful in our code when we need to narrow things down because certain parameters, or certain routes, have parameters while others don't. So to narrow that down properly in TypeScript, we essentially need this type predicate, I believe is what they're called. It's like a type guard, something like that. I don't remember the exact name, but essentially it allows us to force TypeScript to say something is a particular type if it follows these particular rules. Kind of the last TypeScript thing that I have inside of here is called params for path. And really all that this does is it gives me all the different parameters for an individual path that I'd be able to pass along. So if I want to check what are my parameters for my /about/id, this type will help me figure out exactly what those parameters are. It's not used inside this file. I probably should have put it somewhere else, but it's just defined inside of here because I was moving things around quite a bit. So this just kind of hooks up all the different types for things to work. The most important type right here is this registered routes. This is what hooks in the real types from your application with the types from my application. So I can use my own type and it'll properly infer things for you, for your application. For someone else, it'll infer their types. And when I'm writing my own code and I have no types, it'll still work just fine. Now, the next thing that I want to talk about is going to be the define routes function. This is another rather complicated function where almost all of the hard work inside of our application goes. This define route function takes in a lot of different parameters, and this is where the magic for hooking up all the types actually works. You notice I have 4 different generics, and my generics all start with const. What that is essentially telling TypeScript is it's saying, hey, when I pass in, for example, the path of /about, that's saying that that is a constant value that will not change. So instead of typing it as a string, it is actually typed as /about inside of the actual types. This is how I get that hard-coded type safety everywhere. Same thing with parameters, loader, and layout. All these different things are hard-coded types that stay as a constant variable. So instead of becoming more generic, they stay super, super specific. That's how I'm able to get exact type safety for all the different routes inside of my link component, for example, by setting up these constant variables when I define my route. And I have these defined for all the different things my types depend on. So for example, obviously I depend on the path for things like my layout, and for my links and so on, I depend on the path. I obviously depend on the parameters for my parameters, my use params hook, loader for the use loader data hook. All those are super important. The only one you're probably a little confused on is layout. The only reason I have this as a generic type, and maybe I can remove this, but I couldn't find a way to get around this, is specifically for these navigable routes. I need to be able to check which routes have a layout set to true, and the only way I can get a hard-coded true or false value is by specifically saying that I want this to be a constant variable being pulled in as a generic. Otherwise, it just always defaults to a Boolean type because it doesn't know one way or the other. So that's really all that this does, is it sets up all my different types to have these constant values. So that way, when you check for a specific route, it'll get the correct parameters, correct loader, and correct layout information for it. The next thing that I'm doing inside of here is I'm just typing out my route information. Really, all that this is doing is if I have a dynamic route, then I'm going to be checking to make sure my parameters are correct. If my parameters are correct, then it's just going to come in here and it's going to give me the correct type for all my different parameters. Essentially, it's just my normal route without a path. And same thing down here, this is my route with no params. So essentially, if I have a dynamic route, it's going to give me my route with parameters. And if I don't have a dynamic route, it's going to give my route with no parameters. This is what gives me the type safety when I actually come in here and define a route. And for example, if I include parameters but don't put a param, I get an error. Or if I don't have params and I put a param, I get an error. That's where that level of type safety comes in. It's this particular section right here. Now the actual code inside this is rather straightforward. I have all my route information I'm passing along. I'm passing along my path right here, essentially, so I have my path inside my route. I'm passing along my layout here again, only because I need to have this information inside of my thing hard-coded as essentially that layout type. So you can see here, it has that specific layout type right here. That's the only reason I'm passing this along. If I remove this, it doesn't actually work like I expect it to. So I put that in there specifically to make sure the TypeScript information gets passed along. I then have 2 functions. One which uses my loader data, which all it does is hooks into this loader context we'll talk about in a little bit, and it specifically, importantly, types this information. So I'm telling TypeScript, hey, when you call the loader context, I know you're going to get an unknown data returned to you, but I actually know the result of this information is going to be specifically typed based on my loader data. So if I again go back into here, whatever I return as the type from this loader function, that's what this loader generic type is going to be. So I'm telling TypeScript, hey, the result of this is the actual generic type, or not the generic, it's the actual specific layout type for my loader that I specified inside my code. So I'm hard coding that type right here. Same thing with use params. I'm hard coding the return of this to be the parameter generic inside this function, because otherwise it just gives me random information back from my parameters. You can see when I call parse, it just gives me a string.any essentially. I'm saying, hey, I know what this type is. It's going to be this really, super long type, but essentially it's whatever type I pass in when I define my route right here. That's going to be the type for my params. And as you can see, that actually gets passed along properly. So I'm really just telling, hey, you know what, use all this information, but specifically return it as the type that I want to use. And that's what makes this work. By putting these hooks as not global hooks, but hooks on the actual route themselves, it allows me to pass along all that type information properly. Because if I made them global hooks, like something like React Router, it's impossible to pass along that type safe information properly. So all that this define route does is it makes sure all my TypeScript information is hooked up between my router on the back end and your routes on the front end that you've created. It also gives you access to loader information, parameter information, or any other TypeScript specific information you want with custom hooks directly on that route right there. Now, kind of the next thing I probably should talk about is the way that layouts work as well as outlets, because that's a really common thing you'll see in a lot of libraries. You can see we have this outlet, which is just going to render content inside of it. All my layouts have this outlet inside of them, and it's where I render my child content. So if we take a look here in my home layout, it says my router and it has all my links, and then it renders an outlet, and that outlet renders whatever the route is that's currently rendered. So you can see here, it's rendering all this content right here. If I go to the about page though, you'll notice I'm rendering this layout for my home layout. Then I'm rendering this layout for my about, which is why it has an about tag right here. And then finally, if I go to whatever route I'm on, you can see it renders then whatever that context is next inside of my outlet. So it's kind of slowly doing all my layouts as like an onion, almost peeling back the layers one after the other. So if we go to our router provider, down here is where I start that outlet train, and I set the depth to -1. The only reason I do that is because the depth essentially is the place in the array where I want to render this piece of content. So by default, the depth of 0 is going to be the very first thing that I want to render. It's the very first thing in my array, but my outlet always increases the depth by 1. So I start with an outlet wrapper with a depth of -1, and then I increase that to 0 to render my outlet. And this outlet is a special component that really all it does is it hooks into all the different parameters that I have defined here for all my different routes, and it uses that information. So here's that outlet component, It uses my router context to get all my different routes, and it uses the outlet context, which if we go back to that file I was just in, let me just close all these other ones, come into here, you can see that just has our depth parameter defined on it. So we're getting our outlet context, which gives us our depth. And all we're doing is a few simple checks. First of all, if we have a depth that is greater than the length of our array of elements, just return nothing, because that means that we have an outlet, but we have no children to render in that outlet. This shouldn't be something that would happen, but if you put an outlet inside of a component, maybe where it shouldn't be, this will just make sure you don't crash your application accidentally. The next thing I do is I determine what component I want to render by saying I'm going to get my matched route at that particular depth. That's essentially the same thing as just putting this inside of square brackets. If I do that, it's the exact same thing. Both of them do the same thing. I just put the syntax inside of here. So I'm getting my particular component to render. If I have a component, I render it. If I don't, I render an outlet as a fallback. There should be pretty much no world in which you actually render an outlet. That shouldn't be something that happens. But in a rare instance where for some reason this doesn't actually access a particular component, then it's just going to render an outlet as a fallback, which means that it's going to move on to the next element in the array. So if for some reason one of the elements in my array is undefined, or it doesn't have a component or something like that, it'll just render a fallback outlet. Now this outlet wrapper is kind of where the magic happens. If we go to this, it's just defined down here. It's a rather simple function where all it does is it takes my two main contexts, my loader context and my outlet context, and it wraps whatever our outlet is. So my outlet wrapper, whenever I define it, it creates two brand new contexts. So every single level I have, so if I have two layouts and one file, I will have three separate loader contexts and three separate outlet contexts, and they're all nested inside of each other. So when I call, for example, all the way up here, use outlet context, it's getting the outlet context that's directly above that particular element. So whatever is defined this outlet wrapper. And since they're always nested inside of each other, it's making sure that every time I call this, it's only getting the closest one. There may be three different outlet wrappers inside of each other, but wherever you call that, it's only getting the closest one. So essentially it's getting its own unique outlet context, while all of them have their own unique outlet context. So down here, what's happening is I'm getting all my loader data, and for whatever my depth is, I'm passing that information in. So for example, if I want to get my loader data for my very first element, the depth would be 0 in this case. Then I'm just adding 1 to my depth to render my next outlet level, and it just repeats that process over and over and over again. Now I'm sure that I could change around my code a little bit to make these numbers a little easier so I don't have to start at -1 here, but I got it to work and I didn't really want to mess with it, so I just left it as is. A really good way to look at what this particular code is doing though is something like this. We essentially have multiple different outlets with these different wrappers inside of each other. And for each one of these wrappers, we essentially have some code. So this would be like component inside of here, kind of like this, where we have our outlet that wraps our component, which then wraps another outlet, which wraps a component, which wraps another outlet, which in this case would be another component. So as you can see in this component, when I try to access the outlet information, it gets its parent one. This one again gets its parent, and this one gets its parent. So they all have their own unique location where it gets information from. That's how all of this works properly. And this outlet wrapper contains the loader information, so I'm able to get the loader information incredibly easily. For example, inside of my defined route, when I call use loader context, all that that's doing is it's going, okay, I'm in this component, I want to get my loader information, I check my closest outlet wrapper, which as we can see has my loader information, and I'm going to get that data directly from there. So it's relatively straightforward exactly what's going on. Well, I shouldn't say straightforward, it's actually very complicated, and this took me a lot of time to wrap my head around it, reading a lot of source code to figure out, but it overall gives you the exact thing that you want. Essentially, by wrapping them inside of their own context, you make sure that each outlet has its own information for loaders as well as its own information for depth, so it knows what component to render and it knows what loader information to render as well. Now, the final kind of thing that I want to talk about is going to be the link component, and the link component here looks really complex, but it's actually a lot of code that we've pretty much already seen before because this is essentially what the navigate function does. This is where I was talking about I just made this go to URL function to get around some weird TypeScript issues I was having. Because for example, if I try to use navigate inside of here and I pass navigate, and if I come in here and I pass my URL, which is my href, and I pass along my params, which is just my params, you can see I'm getting a bunch of TypeScript errors for this. I spent some time trying to debug this issue and I just said, you know what, screw it. I want to be done with this project. I've spent a lot of time on this project. I'm just going to create a helper function that just takes in a string URL and navigates to that particular URL, and it's going to work fine. So if I was better at TypeScript or I had more time, this function wouldn't even exist and I would just use the built-in navigate function, but I didn't want to mess with it, so that's why we have this go to our URL function. But you'll notice if we look at the actual TypeScript code for navigate, you can see it's taking my navigable routes and it's getting my params for the path or nothing, and it's based on the dynamic route. If I look at my link, it's essentially the exact same code. This is all almost identical. We have my path. If it's dynamic, I get this, otherwise never. It's based on my navigable routes and so on. And really all that this link function does is it generates what my URL should be, which again is code we've already seen before. I could have made this so much better if I deduplicated some code, but I just, like I said, wanted to be done with the project at this point. So I just, not the best looking code inside of here, but either way, I have my go to URL function. And inside that function, all that I do, if we scroll down to where I've defined that function, is I just call window history, pushing the URL, and I handle my route change. So it's relatively straightforward what's going on inside there. All it does is it takes the URL and it's going to handle that route change. And specifically the really important thing inside my link, I'm making sure I prevent the default behavior because I want to do client side only navigation, essentially a single page application. And by not preventing the default, it would do a full page refresh, which defeats the entire purpose of this router. So to kind of show you how this router works and how easy it is to work with, I want to just show you how to create a brand new route. So let's just create a brand new route. It doesn't matter what our page or folder structure is because we define that all on our own. But let's say that we wanted to create a brand new route for like a contact page. So we'll say contact and we'll come in here with like a details.tsx file. So what I would do is I'll just copy all of this because it's going to be relatively similar. You can see here that I have my route. I can call it whatever I want. I'm going to call this my my contact details route. Then I define what my route is, which in my case is contact/details. Now in this particular case, you can see that I particularly matched this to the name of my file, but I could call it whatever I want. For example, we can call this contact/test and it's going to work fine. I'll use that actually as our example. So now we can have our page down here. It doesn't matter what you call this. We'll just call it page. We don't have any parameters, so we'll completely ignore our parameters. And for this, we'll just say, this is our contact page. There we go. So now if I give that a save, I have this particular route defined. I just need to add it to my routes. So we can come in here with our contact details route. And now that has defined that route so I can use it anywhere in my application. For example, on my layout page, let's add in a brand new link. So we can just copy this, paste down this link. You can see here, I now have that contact/test. It has no params, and this will go to our contact page. Give that a save. You can see I have my contact link over here. And when I click on this, you can see it brings me to the contact page. My URL has changed to /contact_test, and you can see everything is working perfectly fine. Now, if you've used something like TanStack router before, you'll know that it's a very similar process. They have a defined route or some other similar function that defines your routes for you. But the big difference is you don't need to manually import your routes like I do here. The reason for that is they have essentially a step in between of code generation where it's taking your route as you define and change your files, it's looking at your files and it's creating this file for you. Essentially all this code is automatically generated for you in something like TanStack router, but that's a whole nother can of worms that I did not want to dive into. So I just took the very small step of importing my route and then declaring my module, and that works just fine for my particular use case. But this step right here is kind of handled for you by TanStack Router by doing all that code generation for you. But again, that's a much more complicated task. Now, another important thing about this project is I wanted to use this project as a way to like really test myself with TypeScript, because as you can see in some of this code, it's very, very complicated TypeScript, and I'm not actually that great of a TypeScript developer. I know looking at this, you may think, wow, he's really good at TypeScript. He wrote all this code, but I am not that great at TypeScript. And this took me a really, really long time to be able to write, parse through, and I still probably don't understand exactly everything that's going on in all these different types. But I also wanted to use this as a way of testing the power of AI. I recently did a video about why I think that you shouldn't really be afraid of AI taking over your job, and I wanted to see how good AI would be at writing out some rather complicated TypeScript code, and this is something not a lot of people do. Very few people write custom routers for React, so this is not something that AI probably has a lot of training on. And I found that it was very, very bad for the most part. It could write me some TypeScript stuff, but pretty much everything that I used the AI for, I would be like, hey, I'm struggling with this particular thing. I would try to prompt it really well. And I tried multiple different AIs and multiple different models. And every time it would just give me terrible code that either didn't work, didn't even come close to doing what I wanted it to, or even if it did work, it would change other things in the code randomly for no reason at all. So I found that the AI was pretty much useless for anything difficult. When it was really simple stuff, yeah, the AI worked fine, but anything complicated, it was entirely useless at, which I mean, is great if you're worried about job security, because this kind of complicated code, the TypeScript can, or the AI is not going to be able to replace you in. But it was a little bit frustrating for me when I was like, hey, I have a relatively good grasp of TypeScript, but some of these more complex things confuse me. So I was like, hey, maybe it can help me write them, and then I can look at the code, read the code, understand what's going on, and use that as a learning point. But it was just so bad. Even when it did give me something correct, it did it in such a strange and not really great way that I ended up rewriting most of the code that it gave me, even when it was correct. It was a great tool though. It wasn't like terrible the entire time. There were certain things where I was like, hey, I want to try to do something. Can you give me some hints or suggestions on what I should look into to do that? And it helped me with like using certain built-in features of TypeScript that I forgot about, or understanding how specific complicated TypeScript code works. But really the best thing for me learning and building this project was looking at the source code for the TanStack router, looking at the React router source code, and just diving into those types of concepts. That's what really helped me with being able to build this particular project. Because I started out trying to build it entirely on my own, got stuck with a few problems, tried my own experimentation, and then I was like, you know what, I wonder what TanStack router or React router did. I looked at their source code and I went, oh, they did it in this particular way. That's really smart. I'm going to try doing something similar inside of my code. And that was really nice being able to look at some senior, really smart developers and look at what their code was and be able to use that, because like I said, AI was giving me some really garbage stuff most of the time. So if you're trying to do complicated things, probably one of the best things for you is use AI. Yeah, let it help you with certain things. But when it comes to the complicated stuff, you're going to have to trust on other code that people have written, reading it yourself, or just your own actual skills as a developer to try to figure out how to write this complicated code. Now, this isn't a project that I'm going to use in any of my code. This router is not great for production use because it's missing a lot of features, and I'm sure there's bugs in it that I haven't encountered yet. So it's definitely not something I built for production or personal use, but it is something I built to learn how different things inside of TypeScript work. I wanted to improve my TypeScript skills, so I wrote this particular project, and I think I did improve my TypeScript skills from this project. I also was curious how these different routers worked. So this project not only forced me to try to understand how they work and build my own, but it also forced me to read the source code of those projects to understand them in even more depth to write out how something like this works. So if you're ever curious about how something works, or you want to take your skills to the next level with some type of learning, I highly recommend trying to take things and just build them for yourself. They don't have to be production ready. They don't have to be things you plan on using. It's really just ways of you saying, hey, I want to be able to use my coding skills to try to build something or learn something and just do a project related to that particular thing. Even if all you're doing is essentially just recreating the wheel by doing something that's already been done before, that's perfectly okay because it's a great learning experience, and I find it's one of the best ways to learn, and I really thought this project was great for helping me learn. And if you want to check out the source code for this project, I will link it down in the description for you, but just remember this is not perfect code. I wrote it rather quickly. It's not optimized or anything like that, but if you want to look at how I actually did these things, I will link it in the description for you. With that said, thank you very much for watching and have a good day. And if you want to see some other deep dive style videos, I'll link them right over here for you.